think.
No.
Like
Okay,
that.
so
I'm not saying like I want.
these particular effects, as I mentioned, for natural selection occur to populations. They have their effects on populations, not on individual organisms. Okay, so a big part of this whole effect overall, as far as what happens in an ecosystem, has to do with population growth. And what we see is that there's two main ways in which organisms will reproduce with the ultimate goal of continuing the species on, and making sure the next generation survives, and so on and so forth. Or strategies is what they call them. That's why they call these K strategists and R strategists. One of them is the K strategist, and if you want to think big K, like, isn't that Kmart? They call themselves Big K or something, even though they're all closing down. But K, yeah, Circle K, but that doesn't really apply to this because these are bigger organisms. That's what I was trying to say, big K. Anyway, K equals capacity. I looked it up because I want to know what the different R and K meant, and I guess it's a German word for capacity. But these particular types of organisms, they tend to be big. They tend to live a long time, which means that, in particular, that they have more than one breeding breeding cycle. And so they will breed multiple times during their lifetime. They tend to have low birth rates, death rates. In a way, both of those are correct when you compare them. So I'm going to go ahead and let you both have a point for that. But overall, we call these fertility rates. It's basically how many offspring on average these organisms have each mating circumstance. Okay? And another characteristic of these is that they care for the young after they're born. So they keep them around for a while. You look at mammals, for example. Mammals actually have a particular organ that is solely for this purpose. Which is what? What am I talking about? For caring for the young. Particular mammalian organ. As a matter of fact, it's where they got their name.
Marsupial. Kangaroo pouch.
No, that's a good guess. Although the pouch is just kind of a pre-embryo kind of thing.
The
but
womb.
this is true of all.
Milk.
Milk is correct, which comes from
The titties.
nipples. Yes. What's the gland called?
Oh, the mammary gland.
Mammary glands. You don't have to grab yourself to show us.
I didn't grab myself.
You
I
did. You went all the back like that. Anyway, mammaries, mammals, mama. Those all come from the same idea, and that, of course, is the purpose of that.
Are girls first in the womb? That's why they have nipples.
What?
I think you were trying to say that.
No, you're right.
Girls
Yeah, like first you look like a female, like as a fetus, and then they grow.
Anatomically, everyone starts out as a girl, and then if they're male,
I was a girl.
then
No, we have wrong.
the ovaries. I don't think that has anything to do with the mammary glands. Apparently, supposedly, with induction, males' mammary glands can actually become activated. Supposedly, if whatever.
But it takes work.
Yeah, but yeah. So, point being, yeah, it is weird.
A guy can do that.
Anyway, totally off subject. So let's guide the plane back. Before you start asking your boyfriends to do weird things, let's get back on subject here. They will tend. Let's not talk about these. They will tend to follow what's called S-shaped or logistic growth curves. Okay, and we'll look at that in a minute. And in that case, they reach a carrying capacity. So, in general, that means their population numbers will tend to. They start out kind of slow as they get settled in, so to speak. Then, once all the conditions are ideal for reproduction, their reproduction will go very rapidly, exponentially, as a matter of fact. But then they hit a point where they've reached the maximum capacity, population-wise, that ecosystem can handle, and then their numbers will level off. That's what we call. That's why they call it an S-shaped growth curve. I know it's not a perfect S there, but that is That's the strategy of populating an ecosystem that these particular organisms take. Once they get up here to that carrying capacity, the reason why they do that, why their population numbers don't continue to grow, is that the density of the population as such becomes a limiting factor. It increases the death rate and eventually reduces the birth rate as well. Those two together, of course, are going to make the population's number, the growth slow, and then eventually the population even out at a certain level. I'm not going to give this to you, Group 3, because it's not technically correct to just say it's a high population, because that depends upon how big of an area that population is in. It's actually when it becomes too dense. Too many organisms per unit area. Okay? And as you might imagine, when that happens, you're going to run out of things. You're going to have resource depletion, food, water, etc., space. All those things that all the organisms require in that area are going to be in short supply, so that's going to be a problem. Another thing that happens when you get a lot of organisms together in a particular area is that disease tends to spread, as you might imagine, because of that density, and that's going to knock back your population numbers. In aquatic ecosystems, now pollution is not usually a problem in terrestrial ecosystems, but in aquatic ecosystems, you're going to build up with waste products. If you've ever tried to take care of an aquarium where there's too many fish in it, you'll notice that it's always a problem, and fish start to die and things like that because of ammonia and stuff in the water that builds up. And then also predation. So we talked about this a little bit. We talked about what a key role your tertiary consumers play in controlling many different populations. When one population gets overpopulated, they can't hide. That's what we mean by exposure. So predators are going to prey on them more so than ones which have lower population numbers, and it will balance things out. So there's your different density-dependent limiting factors. There are others, of course, but these are the main ones. Any questions so far? What case strategists are and how their populations tend to grow and stabilize out and how they're affected by these other things? And then you have R strategists. Now these tend to be small and they have very high reproductive rates. But once their offspring are born, they're on their own. It's just spread out, and consequently they tend to have also high mortality rates in their young.
So like turtles.
Yeah, turtles is a very good example of that. You've seen the things with the sea turtles. They come on, they lay dozens of eggs. They all, hatch. They start to go towards the ocean, and they start getting picked off by a number of different things. They get eaten in the ocean as well. So they're on their own. They will have what's known as a J-shaped growth curve, where their population numbers will grow rapidly, and hence are primarily determined by the rate at which they can grow. That's where the R comes from. And then their population numbers oftentimes will crash. Now sometimes that will happen, and it'll be actually density-dependent limiting factors, but it'll just affect them much more so because their population numbers got so high. But a lot of times we see with these things, they're adapting to seasonal conditions. Boom or bust. So it's either great or it's terrible. And probably the easiest one to think about with this one is mosquitoes or love bugs. So when it's hot and rainy, that gives that means there's standing water around, puddles and things more so. That we'll just use mosquitoes for an example. They can hatch their larvae, and the larvae don't have to worry about getting eaten by stuff, and just the temperature in general is better for them. And so their population numbers explode. You see thousands of them around. And then all of a sudden they're gone. You don't see hardly any of them around, so their populations go up and down. So a lot of times these are weather-determined, seasonal kind of things.
How come they don't just ever die off? Completely?
Well, they have spores, they have eggs, and it's the goal of a population to make it through to the next year. So they have things in place that will ensure that. Otherwise, they'd be gone. They'd be extinct. So. And believe it or not, as much as I hate mosquitoes as well, and we don't even live in an area where you have a lot to fear about mosquitoes from diseases, but they are an important part of the ecosystem as well. And a lot of times they'll be limited by these density-independent things that will happen no matter what the population density is. Whereas these kick into place because the population is too dense and crowded. These happen no matter what, such as fire, floods, things like that, and climate and seasonal changes, weather changes, and also the activities of foundation species. Like we talked about before, foundation species can come in and totally change that environment, and they'll die off because of that. Yeah, like the elephant or people or beavers. Questions?
No.
K versus R.